Good day everyone, I am Nicole Iglesias and for today's video, let us talk about an ellipse. First, let us have our objectives. At the end of the lesson, we should define an ellipse, determine the standard form of equation of an ellipse, and graph an ellipse in a rectangular coordinate system. So let us define first what is an ellipse. Ellipse is a set of all points in a plane such that the sum of the distances from two points or foci is a constant. There are following parts of an ellipse. We have the center. It is the intersection between the major and minor axes. We also have foci. So these are two fixed points inside the ellipse which are equidistant from the center and lays along the major axis. And the singular of foci is focus. We also have vertices. So these are the points on the ellipse collinear with the center and the foci. We also have the co-vertices. So these are the endpoints of the minor axis perpendicular to the major axis. And we have also the lactus rectum. So these are the chord passes through a focus and is perpendicular to the major axis. The key features of the ellipse are its center, vertices, co-vertices, foci, lengths, and positions of the major and minor axes. So just as other equations, we can identify all of these features just by looking at the standard form of the equation. First, let us see this orientation on what we are going to use if we solve an ellipse or a problem using an ellipse. Okay, let us have first the orientation. If it is horizontal and the vertex is at the origin, we have here the x squared all over a squared plus y squared all over b squared is equal to 1. And if the orientation is vertical and its vertex is at the origin, we have x squared all over b squared plus y squared all over a squared is equal to 1. As you can see, if the vertex at the origin, their differences is their denominator. If it is horizontal, their denominator is a squared and b squared. But if it is vertical, the denominator is b squared and a squared. So it is the opposite of these two. Okay, let us proceed to the vertex at HA. So when the orientation is horizontal and its vertex is at HK, we have this equation, the quantity of x minus h raised to the power of 2 all over a squared plus the quantity of y minus k raised to the power of 2 all over b squared is equal to 1. But if its orientation is vertical and the vertex is at the HK, we have here the equation, the quantity of x minus h raised to the power of 2 all over b squared plus the quantity of y minus k raised to the power of 2 all over a squared is equal to 1. And also, as you can see, their denominator is the same as the vertex at the origin and the differences is at their numerator. Okay, to fully understand this orientation, the vertices, let us determine the standard form of an equation of an ellipse. So, let us proceed to determining the standard form of equation of an ellipse and its parts of the plot so that we can graph an ellipse in a rectangular coordinate system. Let us have here an example. The general form is 4x squared plus 64y squared minus 256 is equal to 0. All we need to do is to determine the standard form. And the standard form must be equal to 0. So, to make that standard form, let us transpose this negative 256 so that it can be equal to positive 1 later. We have here the 4x squared plus 64y squared is equal to, since it is negative 256, if we transpose it to the right side, we have positive 256. And in standard form, it should be equated to 1. So all we have to do is to divide itself 256 so that the result is equal to 1. And since we divide it to 256, in this side or in the left side, we also need to divide both sides by 256. Therefore, we have this result which is equal to 1. So it is near to the standard form which is equal to 1, and we need to solve this. So we have to the lowest term, or we have to simplify it to its lowest term. 4x squared all over 256 is divisible by 4. So we have this x squared all over 256 divided by 4, we have 64. So we have the denominator of 64 plus 64y squared all over 256 can also be divided by 64. So we have here the y squared all over 256 divided by 64 is equal to 4. Therefore, we have our standard form. And we hit our second objective, which is to determine the standard form of equation of an ellipse. So this is our standard form. And to plot our coordinates in our rectangular coordinate system, we must have its parts. So we have here the A. Since x squared all over 64 has the highest denominator, so therefore x squared all over 64 is our A squared, and our B squared is the y squared all over 4. And to get our A, we have A squared. So our A squared is equal to 64. So to get A, we have to square root this 1. So square root of A squared, it must be cancelled. So A is equal to square root of 64 is A. So therefore, we have our A, which is equal to A. For our B, we have here b squared is equal to 4. And to get the b, we have to square root this 1. Cancel. So we have b is equal to, the square root of 4 is equal to 2. And for our c, we have c is equal to the square root of a squared minus b squared. And our a squared is equal to 64 minus our b squared is equal to 4. Therefore, our c is equal to square root of 60. And since 60 is not a perfect square, so our c is equal to square root of 60. And with these values of a, b, and c, we can now get our vertices, the co-vertices, and the foci, so that later we can graph in our rectangular coordinate system. So our vertices in this or in this example is V1 and V2. So in V1, the coordinates are 8 and 0. Since our orientation is horizontal and our center is 0 and 0. And then we also have negative a and 0. So our vertices for V sub 1 is where a is 8. So we have this coordinate which is 8 and 0. And for V sub 2 is negative 8 and 0. For our co-vertices, we have the W sub 1 and the W sub 2. So in co-vertices, the coordinates are 0 and B. And for the W sub 2, we have 0 and negative B. So therefore, our co-vertices is 0 and 2. And for our W sub 2, we have 0 and negative 2. And for our foci, we have f of 1, which is c and 0. And for our f sub 2 is negative c and 0. So we have here square root of 60 and 0 and negative square root of 60 and 0. With these values or coordinates, we can now plot or we can now graph our ellipse, or we can now graph it in a rectangular coordinate system. So let us have here our graph. So let us have here our graph. Just imagine that this is a rectangular coordinate system. Okay? 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we also have here negative 1, 2, 3, 4, 5, 6, 7, 8. 7, 6, 5, 4, 3, negative 2, negative 1, then negative 1, 8. Okay, we have here our coordinate system. So we have to plot these coordinates. So we have first, we have our center, which is 0 and 0. So here is our center. And for our vertices, we have the V sub 1 is equal to 8 and 0. So 8 and 0. So we have here the x-axis, which is 8, x-axis, and the y-axis. So 8 and 0. Okay, so we have here our V sub 1. For our V sub 2, we have negative 8 and 0. So we have to plot here. So this is our V sub 2. For our co-vertices, okay, so to simply put it, we will gonna make it here so that you will not, it's easy for you to see. So we will have our vertices, our V sub 1 is 8 and 0. Our V sub 2 is negative 8 and 0. Our co-vertices with sub 1 is 0 and 2. And for our W sub 2 or the co-vertices sub 2 is 0 and negative 2. And for our foci, we have the square root of 60 and 0. And for the x sub 2, we have negative square root of 60 and 0. Okay, so that you can easily see this one to our coordinates or to our point. So, since we are done with plotting V sub 1 and V sub 2, let us proceed to our co-vertices, which is W sub 1, which is 0 and 2. So, here we go with our W sub 1. And for W sub 2, we have 0 and negative 2. And F sub 1 is square root of 60, and the square root of 60 is equal to 7.50 or 7 point something. So we have here our F sub 1. And for our F sub 2, it's negative 7. So our F sub 2. Okay, so we plot those and these values or coordinates, and all we have to do now is to graph our ellipse. So we have here and there you go. Here is our graph of ellipse in a coordinate system in the standard form x squared all over 64 plus y squared all over 4 is equal to 1. Let's have another example. So we have here the general form 144 x squared plus 9y squared minus 1296 is equal to 0. So, to determine its standard form, we have to equate this one into 1. So, as our example earlier, we have to transpose this one so that we can equate it into 1 later. So, we have 144x squared plus 9y squared is equal to, from negative 1,296, if we transpose it to the right side, it will become positive 1,296. Okay, to equate this into 1, we have to divide it by itself, which is 1,296. And since we divide it into 1,296, in the left side, we also need to need to divide it by 1,296. Therefore, 1,296 divided by 1,296 is equal to 1. And then here, 144x squared all over 1,296 can be divisible by 144. So we must simplify it to its lowest term. And since 1,296 can be divided by 144, so we have here x squared all over 1,296 divided by 144 is equal to 9. And 1,209y squared all over 1,296 can also be divided by 9. So we have y squared all over 1,296 divided by 9 is equal to 144. So we have here our standard form, which is equal to x squared all over 9 plus y squared all over 144 is equal to 1. And therefore, our a sub a squared right now must be here, since this has the highest denominator. So a squared, and this is our b squared. To find the points or to find the plots for our vertices, co-vertices, and foci, we have here the a. So a is equal to a squared, just like earlier, which is our a squared is 144. So to find this one, all we have to do is to have square. So our a right now is equal to 12. So we have the value of a. And for b, we have b squared is equal to 9. And to get the b, we have to square is 1. So b is equal to 3. We also have here the value of b, which is 3. And for our c, all we need to do is to find its sum. So a squared, the square root of a squared minus b squared. So our a squared is 144 minus 9. We have here the square root of 135. And since square root of 135 is not a perfect square, so our c right now will be equal to square root of 135. Okay, we can now find our vertices, the co-vertices, and the foci. So for our vertices, we have V1 is equal to 0 and A. And our V sub 2 is equal to 0 and negative. So, since our orientation is vertical, so therefore we have these vertices, which is the coordinate system is 0 and 8 and 0 and negative 1. So 0 and A, we have 0 and our A is equal to positive 12. So we have here 0 and 12. And for our V sub 2, which is 0 and negative 8, so we have 0 and negative 12. For our co-vertices, we have the W sub 1 and the W sub 2. So we have the B and 0 and the B, negative B and 0. So we have right now, which is equal to 3 and 0, and our co-vertices sub 2 is negative 3 and 0. And for our foci, we have F sub 1 and F sub 2. So we have 0 and C and 0 and negative C. So our F sub 1 is 0, and we have here the square root of 135. And for our F sub 2, we have 0 and negative square root of 135. Since we have these coordinates, we can now plot our graph. We have here the x-axis and the y-axis. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We also have here 1, 2, also have here for our x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. We also have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, we will now plot all those parts of the coordinates. So we have our center, which is 0 and 0. And for our vertices, we have 0 and 12 and 0 and negative 12. So 0 from the x-axis and 12 for the y-axis. So we have here our V sub 1. And for our V sub 2, we have 0 and negative 12. So V sub 2. For our co-vertices, we have 3 and 0. And the W sub 2 or co-vertices sub 2 is negative 3 and 0. So we have 3 and 0, which is our co-vertices sub 1, and negative 3 and 0, which is our W sub 2. And for our foci, we have 0 and 135, and if we calculate this square root of 135, it approximates to 11.62. So we have 0 and 11.62, so it must be here, which is our f sub 2, and our f sub 1, and our f sub 2 must be here. Okay, I'm sorry for the graph since we have now that much. We have not that much area, so just imagine this 11.6. So we have here to sketch our ellipse. We have here okay, so here is our ellipse, and as you can see, it is an ellipse of the standard form x squared all over 9 plus y squared all over 144 is equal to 1. Let's have another example which the center is not 0 and 0. So we have the general form we have x squared plus 2y squared minus 2x plus 8y minus 11 is equal to 0. So as you can see, our center is not equal to 0, just like our previous examples. So we have to regroup this form. For regrouping, we have x squared minus 2x plus, we have also here another group which is 2y squared plus 8y is equal to, we need to transpose this one since later we will need to equate it into 1. So from negative 11 we have positive 11. And then, so this is the square of binomial. So we need to factor our binomial. So we have here x squared minus 2x. Since we need to factor out, so we need to put 2 in this, and then y squared plus 4y is equal to 11. So as you can see, it is factored out into binomial. And by completing the square, we have the formula b squared all over 2, where our b is the coefficient. So we have in here, we have our b is equal to negative 2 all over 2. Okay, this must be b all over 2. b all over 2 raised to the power of 2. So we have negative 2 divided by 2 is equal to negative 1. Raised to the power of 2, we have 1. So in here, by completing the square, we have x squared minus 2x plus 1 from this. And for this term, we have d all over 2 raised to the power of 2 is equal to, our coefficient is 4. So we have, for completing our square, so this is our basis. So the coefficient in this term is 4. So 4 all over 2 raised to the power of 2. So 4 all over 2 is, 4 divided by 2 is 2. Raised to the power of 2, we have 4. So we need to add 2y squared plus 4y plus 4 is equal to 11. And since we add 1 and 4 here, we also need to add in this side. So we have 1 plus. And since we have here the coefficient of 2, which is, we need also to put it, and 4. Okay. And to square and to square the binomial, so we have the factor or square this term. So to square this term, we have x squared, x minus 1 squared plus 2. The square root of this one is y plus 2. The power of 2. Okay, and if you solve this one, it would come up with this. And if you solve this one, it would also come up with this. Is equal to 11 plus 1 is equal to 12 plus 2 times 4. So we have here 8. So 11 plus 1 is equal to 12 plus 8. We have 20. Okay. And to equate it into 1, we have to divide it by 20. And since we divide it by 20, we also need to divide both sides by 20. So we have equal to 1. And x minus 1 squared all over 20, since we cannot simplify it to the lowest term, so therefore we have x minus 1 squared all over 20 plus 2 times the quantity of y plus 2 raised to the power of 2 all over 20. Since we can simplify it to its lowest term, so we have y plus 2 squared. So 2 and 20 can be simplified into 10. Therefore, the standard form of this general, from this general form, we can now have our standard form, which is the quantity of x minus 1 squared all over 20 plus y squared, y plus 2 raised to the power of 2 all over 10 is equal to 1. Since I had given some of examples, I hope that you learned, and with that, you must answer this general form, which is all you need to do is to determine the standard form of the equation of an ellipse, and also to plot or to graph it in a coordinate system. So I will give you 3 minutes to solve this one. Time's up! Okay, let us check your answer. So we have 9x squared plus 81y squared is equal to, from negative 729 to transpose in the right side, we have 729. Next, we have to divide 729 so that it equates into 1. So 729 and 729. So we have equal to 1, and 9x squared all over 729 can be simplified to lowest term, or it can divisible by 9. So 729 divided by 9 is 81. So we have x squared plus 81y squared over 729 can be simplified to the lowest form, or 729 is divisible by 81. So 729 divided by 81 is 9. So we have y squared. Therefore, this is the standard form of our equation, or from general form. And since x squared all over 81 is as the highest denominator, therefore, it is our a squared, and y squared all over 9 is our b squared. So to find a, we have a squared is equal to 81. And to get the a, all we have to do is to create this. So cancel out. So we have a is equal to 9. And for b, we have b squared is equal to 9. And to get b, we have to square this 1. So b is equal to 3. And for our c, we have a squared minus b squared. So our a squared is 81. So we have 81 minus 9. So we have our c is equal to square root of 72. And from this given value, or from our solutions, so let us define our vertices, the co-vertices, and the foci, so that we can plot it in a graph. So v sub 1 is equal to, we have a sub 0, a and 0. For our v sub 2, we have negative a and 0. So our a in this is equal to 9. So we have 9 and 0. And for v sub 2, we have negative 9 and 0. For our co-vertices, we have the w sub 1 and the w sub 2. So for our co-vertices, we have 0 and b, and 0 and negative b. So the value of our b is equal to 3. So our coordinate must be 0 and 3, and 0 and negative 3. For our foci, we have f sub 1 is equal to c and 0. F sub 2 is equal to negative c and 0. Therefore, our c and 0 is square root of 72 and 0, and negative square root of 72 and 0. Okay, since we have these coordinates, we can now plot it in our graph. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We also have negative 1, negative 2, negative 3, negative 4, 5, negative 6, negative 7, negative 8, negative 9. We also have here negative 1, negative 2, negative 3, negative 4, negative 5, 6, 7, 8, 9. And we also have here 3, 4, 5, 6, 7, 8, 9. Okay, so let us plot these coordinates. So our center is 0 and 0. For our vertices, we have 9 and 0. So x-axis and our y-axis. So 9x and 0 for y. So we have here the v sub 1. For our v sub 2, we have negative 9 and 0. V sub 2. For our co-vertices, we have 0 and 3. So we have here our co-vertices. And for the other one, we have 0 and negative 3. And for our foci, when we calculate square root of 72, we came up with the approximate of 8.49. So 8.49 approximated to 8.49 and 0. So to plot this one, we have 8, negative 8.49 and 8.49 is our f sub 1 and our f sub 2 is negative 8.49 also. And yes, we can now sketch our graph. So from here, we have this to this, this. Okay, this is our graph in our rectangular coordinate system with these coordinates. That's all. Thank you. I hope you learned in this tutorial and see you soon. Bye. Or it can divisible by 9. So 729 divided by 9 is 81. So we have x squared plus 781 y squared over 729 can be simplified to the lowest form, or 729 is divisible by 81. So 729 divided by 81 is 9. So we have y squared. Therefore, this is the standard form of our equation, or from general form. And since x squared all over 81 has the highest denominator, therefore it is our a squared, and y squared all over 9 is our b squared. So to find a, we have a squared is equal to 81. And to get the a, all we have to do is to create this. So cancel out. So we have a is equal to 9. And for b, we have b squared is equal to 9. And to get b, we have to square this 1. So b is equal to 3. And for our c, we have a squared minus b squared. So our a squared is 81. So we have 81 minus 9. So we have our c is equal to square root of 72. And from this given value, or from our solutions. So let us define our vertices, the co-vertices, and the foci so that we can plot it in a graph. So V sub 1 is equal to, we have A sub 0, A and 0. For our V sub 2, we have negative A and 0. So our A in this is equal to 9. So we have 9 and 0. And for V sub 2, we have negative 9 and 0. For our co-vertices, we have the W sub 1 and the W sub 2. So for our co-vertices, we have 0 and B and 0 and negative B. So the value of our B is equal to 3. So our coordinate must be 0 and 3 and 0 and negative 3. For our foci, we have F sub 1 is equal to C and 0. F sub 2 is equal to negative C and 0. Therefore, our C and 0 is square root of 72 and 0 and negative square root of 72 and 0. Okay, since we have these coordinates, we can now plot it in our graph. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We also have negative 1, negative 2, negative 3, negative 4, 5, negative 6, negative 7, negative 8, negative 9. We also have here negative 1, negative 2, negative 3, negative 4, negative 5, 6, 7, 8, 9. And we also have here 3, 4, 5, 6, 7, 8, 9. Okay, so let us plot these coordinates. So our center is 0 and 0. For our vertices, we have 9 and 0. So x-axis and our y-axis. So 9x and 0 for y. So we have here the v sub 1. For our v sub 2, we have negative 9 and 0. V sub 2. For our co-vertices, we have 0 and 3. So we have here our co-vertices. And for the other one, we have 0 and negative 3. And for our foci, when we calculate square root of 72, we came up with the approximate of 8.49. So 8.49 approximated to 8.49 and 0. So to plot this one, we have 8, negative 8.49. 8.49 is our f sub 1 and our f sub 2 is negative 8.49 also. And yes, we can now sketch our graph. So from here, we have this, to this, this. Okay, this is our graph in our triangular coordinate system with these coordinates. That's it. I hope you learned something from our discussions for today. I hope to see you again next time. I am Nicole Iglesias. Thank you.